All right, I think it's noon. Let's get started. Uh, this is the Friday, the last set of meetings, so brave souls are here. And if you are for content delivery networks interconnection working group session, then you're at the right place. Um, so let's get started. Let's start with Note Well, as you are all familiar with it, and you've probably seen this all through the week. And just a couple of points just to still remind you that you, by participating here, you're agreed to follow the IETF processes and policies with respect to contributions. And if you have any patent on anything that you are working on, you must declare that. And also code of conduct is, you've got to follow that as laid out in the Note Well. Okay, that said, let's move on to a couple of tips. Again, this is really redundant. If you've been here all week, then you know everything here. And just a reminder, though, that you got to wear your masks unless actively speaking at the microphone here. And also, so you've got some rules for the in-person participants. Make sure that you use the Meet Echo and to make sure that you are signed on. I don't think we have that on display here. And I didn't include that in my uh, meeting presentation, but you can scan that outside the room. If you enter the room, there's a scanner there that you can scan in. And also, if anybody that's remote, you're already in, so you already are pretty familiar with your audio video functions. And if you have any questions, make sure that you raise hands to get into the queue. Okay, and again, a couple of other resources that if you need to go find. And then with that said, Kevin, do you want to walk through this, or shall we just go through the agenda first and then come back here?
Yeah, so since last time we met in Philadelphia, we did submit the CDNI footprint types draft to the ISG. Francesca, welcome back. We're glad to see you. You hopefully saw the Shepherd write-up and for the footprints draft. Awesome, thank you. And we also did the call for adoption for the capacity draft. Andrew and Ben are here to talk about it. Otherwise, we're hoping to get the Acme Star delegation done very soon. I saw the new draft is out from Frederick. I provided some comments this morning. I think we're pretty close to getting that out, and hopefully we'll get that submitted shortly after this IETF. And then, of course, we lost the slides, Sanjay.
Yeah, I just realized that. So
no worries.
Let me go back again.
We still have a couple of other things work in progress. The other delegation draft, as well as the update to the triggers interface, which I think Sanjay is going to talk about.
All right, I think I got the slides back on here.
Yep, I think we've covered it all.
Okay, all right. But that said, I don't think I actually called out my name. So I'm Sanjay Mishra, and my co-chair Kevin is remote, as you see him. All right, so let's look at the agenda here. We've got a pretty packed agenda. So we've covered the Note Well, and we do need Jabber Scribe and minute takers or taker, if anyone that will volunteer for it. Anyone in the room?
I can do it, Sanjay.
All right, Kevin, thank you. Okay, so that being said, we've got 4 working group drafts that are active. So we want to walk through these 4, and then we've got an update from Chris Lemons on streaming media tracing. He'll talk about it. And we've also allocated some time on open mic. And I see Alan Arolovich has joined, so he might be able to use that time to um, for a couple of items that he's working on that he wants to bring to the working group. But he didn't have enough. He was not in time to submit the draft before the cutoff. So we'll have some time for you, Alan, at the open mic for you to talk. Um, So anything on the agenda bashing, anything, anybody has any questions, anything you want to add, remove, or have questions on?
I see Alan is in the queue. Alan, did you have a question or is that just an inadvertent queue?
Just for open mic. Yeah, so I can leave you in the meantime.
Got it. Great. And then just a reminder, presenters, please turn on your cameras. Other folks, please turn off your cameras just to help save the bandwidth.
All right. With that said, so let's walk through, let's spend some time on the working group documents. We've got about 60 minutes and we have about 4 different work streams. So the first one is the HTTPS delegation using star. So Fred, actually, we have you first. Sorry, I didn't realize that, but yes, we have you first. So if you're ready. And let me see if I can bring up the slides.
So hello everyone. I will make a quick update on the draft we are co-authoring now for quite a lot of time on HTTP delegation for Acme Star. Next slide, please. So far we have changed a few things in the last version, which is a 12 version. We clarified the abstract to better give an overview on the Acme delegation. We renamed the object that we are dealing with in the draft. We change also the figure on the bootstrapping code flow. So hopefully now it's getting clearer on that too. And we corrected various typos. Next slide. Also, we made quite a few changes also on the object we are dealing with, according to discussions with the RFC 8739 authors. So they are authoring the draft on Acme Star. So based on those discussions, so first we added the draft on the GitHub, but we also added some properties in the Acme delegation object to indicate the certificate's validity window. We also supported now non-star Acme delegations, which were missing in the first versions of the draft. So it means that we are meaning to support long-term certificates by adding lifetime and lifetime adjust properties. So according to the RFC 8739. And we provided examples for both star and non-star delegation methods. So hopefully here too it's getting clearer. And finally, we added a section on acknowledgements. Next slide.
All right.
So what's next? So now we are proposing to change the draft name to CDNI metadata for ACME delegations, which seems more accurate than the current draft name. And also, we are asking now for a bit of time the working group last call. So hopefully now we are reaching the good end of the work. And so I saw that Kevin already reviewed the draft. So to me, it should be now very quick to take them into account, to take the comments into account. So normally, yeah, we should reach the last mile on this. So thank you.
Great. I gotta go back in because I was trying to scan here, log me out. So give me 1 second here. So Fred, based on, I did see email from Kevin where Kevin has responded back with some nits, and there are a couple of key comments also on some of the designs. So I guess you got to follow up on that.
Yeah, I think it's doable for the next few weeks.
Okay.
Yeah, I did this pre-Shepherd review. I think it's in pretty good shape. It's much better than the previous version. So thank you for that. There were a couple of comments I had. The JSON example doesn't match what is specified, so we need to clean that up. And then I think we could still beef up the security considerations a little bit, but otherwise I think it's in pretty close shape. Thank you for all the work. I think we can probably get to working groups last call before the next IETF once the next version comes out.
Yeah, hopefully it should be done for the next IETF. Yes. Any questions so far?
Thank you, Fred.
Thank you.
Okay. I think next on the agenda we have Guillaume. Let's see if I can bring up the slides here.
Hello, can you hear me?
Yes.
Good. So, yeah, I'm presenting the this contribution on behalf of Christophe that could not join today. By the way, in France today it's an half day, it's a holiday. Okay, so let's go with this draft. So can I control the draft, the slides from remote? How does it work?
You could
Sanjay,
request. Yeah.
can I control the slides remotely
I'm
or what?
trying to. Let me move ahead. I think maybe just easier.
Yeah, okay.
Just tell me. Yep.
Yeah. Okay, so we have had a couple of exchanges between. There have been a couple of exchanges between Christophe and Kevin, I think, and they ended up with this draft IETF CDNI HTTPS delegation subset 00, and there was something. It was not completely satisfactory because it somehow used FCI for something that was not designed for. Yeah, because with FCI, with the object delegated credentials, we expect from the FCIs to announce, I mean, to use FCI each time the delegated credential expired, which wasn't not really the way we should have used FCI. FCI is used for announcing, exposing the capabilities, and not really to, to use as a channel for interactive protocols or such kind of thing. So this was not really satisfactory, right? And and anyway, we had that was a step so far, and there has been a proposal to try to correct this main default, if I can name it like that. So can you go to the next slide? Yeah. So basically, that's what we have today. We have two objects in FCI. We have currently in the draft, right? We have in FCI an object that is used to express for the downstream CDN to express the need, let's say, the need of, the capacity of ingesting a certain number of delegated credentials. So that means here 3 means you can send me up to 3 delegated credentials, and I will know how to deal with it. That's more or less what it means. But on the delegated credential object, the MI object, the configuration object, that was up to the upstream CDN to send these delegated credentials, right, according to the number requested by the downstream CDN. I mean, requested, yeah, and announced, exposed. So, yeah, next slide. Yeah, so as explained, so in slide, as explained, it's not, FCI should not be used as a kind of signaling protocol. It's more about signaling and announcing the capabilities more than using it for signaling. So that was the drawback of this method. Kevin proposed one thing was to completely remove the FCI object. And instead, he proposed to rely on only on delegated credential objects and operating, it was, the proposal from Kevin was based on the fact that the metadata, MI metadata, resides on the upstream side, and his proposal was based on the fact that the downstream CDN can download and fetch the configuration at any time. This is and this proposal was also based on the fact that we could let's say relate objects in the configuration metadata. We can operate how do we call that, links? I don't remember exactly the names, but it was based on this. But we have a problem with this proposal because first, in SVTA we don't support links, reference links, at least in the first version of it. And furthermore, we have 2 ways to configure a downstream CDN. It can be either the pull mechanisms like Kevin was, assume, but we can also use the push mode where the upstream CDN push the configuration using a particular API to do that. And in that case, the references, the link methods, to reference object between them are not supported, or even forbidden. So basically, your proposal, Kevin, cannot work with SVTA 1.0, at least not in all modes. That's my problem. So instead, we have proposed something else to remove the drawback brought by operating FCI beyond its original design. So we propose to keep this FCI object, but instead we would change the semantic attached to this FCI object. So the FCI object would now, in our new proposal, would be used to announce the maximum delegated credential that we support, right? So this is really, and that's it. And the FCI won't be used anymore for announcing that the delegated credential need to be refreshed, like it is today, like it is described today in the current draft. No, FCI object only used to announce the maximum number of delegated credentials. Then the upstream CDN will use this MI object to configure a certain number of delegated credentials. It can correspond to the maximum number advertised by the downstream CDN through FCI, or it can be less, right? It can be only, for example, one. So it doesn't change from what we have described already in the spec. And when the credentials, the delegated credential is going to expire, it's not the downstream CDNs to manage that. It's up to the upstream CDNs to manage this and to reconfigure the downstream CDN with a new delegated, with a refresh or new delegated credential, because the previous one, because it knows the upstream CDN is supposed to know exactly the life, the duration of the validity of a delegated credential, and it will be up to the upstream CDN to refresh it and to reconfigure it. That's basically our proposal. Hopefully I was clear enough for you to understand. And now I'm open to questions.
I see Neer in the queue. Neer, go ahead.
What is the method? Just to better understand the entire picture, sorry.
That's okay.
How the downstream, so it's the middle of the noon and the Friday as well. What is the procedure for the upstream CDN to update or send the credential to the downstream CDN? Is it using the triggers interface, for example, or
No. It used what we have in SVTA. It used basically we call it the configuration method. In SVTA, we have two ways to configure the downstream CDN, right? So either you can use the trigger interface, or you can use the simple, what we've defined as a simple configuration interface, which is basically a put interface. It's a REST put interface, right, where you just provide the complete configuration structure or a part of the configuration structure, right? So you can do that in such a way that you can just modify the part of the configuration and including, for example, if you want to refresh the
and it allows also the removal of the interface.
Yeah, of course. Yeah, the interface allows to remove, and it allows to modify the configuration. The downstream configuration.
All right, I'm going to insert. I'm in the queue next. I'll go. Neer, you good? Okay. The only question I have is that asking the UCDN to know the renewal period, that might be a little bit more tricky for the UCDN to kind of try to keep track of this. I'm just wondering if the design should take into consideration where the downstream CDN is responsible for knowing when the certificate expires, and it makes a request to fetch a new certificate rather than relying on the upstream CDN to remember this and send it down.
Yeah, I understand. And that was part of the problem, right? We have to find a compromise, right? It's a trade-off. And we've been against creating and designing a new interface, because for what you are saying, Sanjay, we need a new interface. And at the beginning, we've proposed this new interface, but it was too much. We thought that we could do without this new interface. Then we have these ideas of operating the FCI as a kind of return channel for kind of, like a bit that we used to do that for also for capacity insight, for example. So, but it was FCI has not been designed for that. And again, I agree with this with this conclusion, with this remark. And then we have this proposal. It requires the upstream CDN, yes, but frankly, the upstream CDN has to know what it's doing, right? So if it has created delegated credential, it has to manage that, right? You cannot let credentials without So that's a trade-off. If you want the downstream CDNs to take care of the refresh, by the way, I think the downstream CDN will take care anyway. So if the downstream CDN knows that the delegated credential is going to expire, and there is nothing has been sent for refreshing that delegated credential, it will take care of it. Don't worry. The thing is that we don't have mechanisms because we don't want a new interface, so we just have to rely on the upstream CDNs just to do his job. And if he cannot do it in time, there will be something else. Probably, I don't know how, but exactly. But we have different methods. It's more about implementation issue here, right? If, for example, only one delegated credential is renewal and not the others, then we can share the delegated credential among all the servers, for example. It's one way to cope with the problem of having the upstream CDN just late or just, such kind of things. So we may have methods, right? But yeah, we thought that we should try to be simple as possible. So this proposal is quite simple. Doesn't solve everything. It has some burden. It provides some. It has some disadvantages because for the upstream CDN, that, like you said, it is obliged to follow it, to track this and this refresh period and to regenerate. But anyway, the upstream CDN will have to work anyway. We'll have to provide new, even if the downstream CDN manage this expiration and request somehow to the upstream CDN a new delegation credential. The upstream CDN will have to deal with that anyway. So,
okay, yeah, thanks, Kevin.
I guess I'm still not understanding why the metadata doesn't work by itself, right? The downstream CDN can re-request the metadata, or the upstream CDN can use triggered pull. We support triggering refresh of metadata. So there are mechanisms built into CDNI to do this. Whether or not they're your preferred method, there are mechanisms. And if you want to build a separate mechanism outside of it and have a different configuration interface, that's fine. That's not really within scope here, but it doesn't really matter. But I guess I still don't understand why pulling the metadata itself is not enough. Now, I don't mind, I think, if you have a new FCI object, but that's not really the issue here, right?
Well, pulling the metadata is one thing that has been the basis of the CDNI RFC, but we are adding a new possibility that will also be part of CDNI somehow, I think, because it's part of our proposal to modify, to add some features in CDNI. And this, one of the features is that the metadata is not only pulled, is also pushed, right? So that doesn't change that much, right? It's just that pulling is just an option. It's not the only one. That's my problem.
And triggered pull's not as good as a push.
No. That's concretely when we start to develop the fact that the upstream CDN needs to keep the metadata and continuously and wait the pull method, the pull request to served. It was viewed as sometimes as problematic, and the first implementation did not do that. They rely really on the
I guess I'm still not understanding how that affects this particular draft, right? Even if you had push support for metadata to force it to update, the metadata object itself doesn't change necessarily. Right. And so if we did add that support later, whether you implement it outside CDNI or CDNI implements the ability to push new metadata, it shouldn't change this particular object or this particular use case.
Right. So
I mean, we should still be able to define in this draft what information is needed and how to use it. And if we add another, and we could even specify triggered poll and, you know, that sort of thing. And if we add something new in the future, then it should also be supported. I guess, do we
okay.
have to debate
I'm
that
okay.
here?
Yeah, I'm okay with that. It can be an option. So then we can have two ways. I have no problems. We just want to bring our option here as still have a valid options. That's my point. Right.
Okay.
So
Understood.
if I well understood, you are saying that we should keep maybe both as two possibilities to control the refreshing of the delegated credential, right? That's what you're saying. The first one being based on what you proposed, and the second one be based on what we proposed.
Possibly, yes. I'd want to see the text, but in theory, that doesn't break anything.
What do you think about our proposal, our changes, our proposal?
I'm sorry, is there a new draft? I haven't read it.
No, we didn't have time to submit a new draft. So basically, you have the ID on the bullet on number 2.
I don't know. I don't think I can make that comment right now.
It was based on what I tried to explain the change that we propose to bring in this current draft. So basically, what we are saying that FCI object is still there, but it is not used to manage the expiration. It is just used to announce the maximum number of delegated credentials that the downstream CDN support. Right? That's it.
Yeah, I don't have a problem with that. I don't have a problem
that's
with
it.
that.
And then the rest is managed by the upstream CDN with the MI object.
Yeah.
I think Fred also has a comment. So maybe it's certainly. I think this issue we need to maybe reply back a little bit more in the mailing list and talk through this to make sure it's clear the path. I understand that FCI is making request. FCI why you're using it, but we still are not clear on some of the design that you have in number 2. So let's take it on the mailing list also. Fred.
Yeah, Fred IQ. I had a question for the working group. I was wondering if the FCI objects we define in both draft, I mean the both delegation draft on ACME star and delegated credential draft should be aligned. That means that we should have the same way of defining things. So is it important to have both draft aligned on this or not?
I'll respond to that at least, and Kevin can also chime in. I technically it would be easier if this draft follows the how the delegation is using the ACME delegation, where you have the FCI and also using the metadata interface to request updates from upstream CDN. So logically, it seems like the delegated credentials can follow the same mechanism, but I don't think we want to make a decision about that here particularly. Definitely need to talk this through more in the mailing list to see if there are other ideas. But it seems like it would be easier if this draft also follows the previous version. I mean the other draft.
I think it would be nice, but I think in this case they have an additional parameter. It's not just an enable, disable. Is it supported or not? They also want to supply an integer parameter, which doesn't fit within the same model. But I think we can think about that.
Okay, thank you.
I think that was the intent of my original comment, was to align them. But if it doesn't work for them, then obviously we come up with a different method.
Yeah, agree. It doesn't. I mean, the FCI object is slightly different, at least for now. So whether to merge or not the two FCI objects in one is really a secondary to me. Just let's try first to resolve the mechanisms, right? And then we can discuss about merging or not.
I think to be clear, Fred is not asking to merge. He was sort of suggesting if could this delegated credentials follow the pattern for the ACME delegation, but it could, but it doesn't have to. But I'm not sure. Just to be clear, Fred is not asking for merge, so I was not sure if you're
no merging
merge
the FCI object. So what is the pattern?
They don't have an FCI object. They don't have a custom FCI object. They're using the existing metadata FCI object just to advertise that there is support for ACME delegation.
Yeah, exactly.
They don't have to pass any other information other than
So that's nothing. So then there is no point, right? We have an FCI object, so for the moment there is no point.
Okay.
I think Fred's question is, can you also get away with just using the existing metadata object to advertise enabling, disabling without the need for passing the parameter, the max credentials, which is my original question. But if that's not the case, then we have to.
Yeah, of course. No, but we can't, right? We need this maximum for the moment. I mean, if we end up with removing these parameters, then of course. But for the moment, we need this parameter, right?
Okay, Guillaume, anything more on your slides, or this is the previous one
No.
was the last one, I guess?
No, that's it.
Okay, thank you. Let's see, so we have Andy, you're next.
All right, everyone hear me clearly?
Yes.
All right. So Sanjay, thanks for putting together the slide deck. Appreciate it. So I'm on here with Ben Rosenblum as well. We're here to discuss some updates on or progress on the capacity signaling component that we're proposing. Next slide, please, Sanjay. So, I mean, just to highlight without reading through the slide, the overall goal here is to allow a mechanism for delegation partners to understand how much traffic is appropriate to delegate. I think this was a topic that was deferred from some of the original CDNI specifications, probably due to some of the complexity, but it's definitely in practice something that is identified as being a key component to making sure that the traffic steering is done in an intelligent manner. We wanted to make sure that the signaling that is done, though, is specific to the upstream and the downstream. The limits are non-ambiguous, so it's the limits that are defined aren't calculated independently by each participant. There's a common source of data that is being used to measure utilization and then also tracking limits against that utilization. Yeah, next slide, please. So some of the points that have been raised on the mailing list are, points that have come up in some of the discussions. The one main point of contention, I think, with this model is we've identified is what we've defined as a subscope within an FCI payload. So to take a quick step back, how we're proposing to accommodate this workflow is we're creating a new FCI payload. And the reason why we wanted to take this approach is FCI was very aligned with the concept of capacity signaling, particularly the fact that the FCI object is tied to a footprint, and the footprints are very readily tied to infrastructure underneath that the downstream CDNs would be advertising or supporting capacity from. So there was a very strong case to leverage FCI for this purpose. When we got into some of the use cases, though, we found that the FCI footprint may not be as granular as we'd like. A particular use case is if you've got a upstream CDN who is attempting to delegate a wide portfolio of traffic to the downstream. For example, the upstream CDN is dealing with a game download company, a streaming company, a website company, all of which, all of those traffic portfolios are very different. Whereas the downstream CDN may want to provide limits specific to that traffic, to a particular traffic type, i.e., you will allow X amount of gigabits per second of your game traffic, but if you're going to start sending us and delegating low latency HLS traffic to us, which would have potentially a much higher request per second portfolio, that may be something the downstream CDNs want to signal in a more granular manner. To accomplish this, what we proposed in the new FCI capacity limits object we're creating is the definition of a scope, and that scope would essentially live inside of the payload. It would be encompassed within the footprint. It would live inside the payload and would allow for a more granular definition of what does the limit that we're proposing apply to within the greater footprint. Some of the identifiers we've linked in there are the published host, and then two other identifiers which kind of link and point or are meant to reference specific configurations on the downstream CDN. As Kevin has pointed out, that's not necessarily a standard practice. There's some ambiguity in there, or there is a sense of ambiguity in there. We tried to address that in the specification by kind of coming up with guidelines on how this scope object should be evaluated. And it's, at the end of the day, it really boils down to all requirements need to be evaluated and accounted for. It's not an order of precedence per se. It's not a logical or. It's an and. Everything has to be met at this point. We provided on the mailing list an example of a payload, what it would look like with some of the scoping defined. So I guess that seems to be one of the biggest points of discussion here that we're hoping to kind of raise up and solicit some feedback on. Sanjay, I'm not sure if there's any additional slides at this point, but I think that was probably one of the biggest things we wanted to talk about here. Oh, okay, here we go. So sorry, I jumped ahead in your slide deck. So at this point, I guess we open the floor for conversation. Kevin, I think particularly you in particular.
Thanks. Yeah. Thanks for the email. Thanks for clarifying that. I think I understand what we're trying to do now. I was actually just thinking with the new footprint union type and the clarification, we do have the ability to now specify this as footprints, I think, right? And if we added a new footprint type, which was, the host or something related to how it's being retrieved, it would be really nice, I agree, if it related to the metadata host. That would be cool. I don't know if there's a good way to hard link that. It's possible because we do have the link references from metadata, or if we just wanted to make it, this should match up with something and figure out how to do it, we can always put that in there. And that's a detail we can figure out. But I think that makes sense. It makes a lot of sense, and we didn't consider it originally. I think there's probably still a way we can do it with footprints. I think I originally was thinking it wasn't a footprint thing, but now that I understand what we're talking about, it feels okay. It seems somewhat natural. So I would be in favor of exploring that route.
I mean, I don't want to speak for the larger group, but I feel like that makes sense as well, because it makes sense. And the only other counterpoint I'd say where it could be challenging, right, is when we're dealing with what is the delegation model. Now, typically, like we've been highly focused on like the DNS delegation model, at which the most granular delegation element would be DNS. We really can't get into host at that point. So, for example, if there's a client where there's multiple traffic types served under the same publish host, like /live, low LL live is low latency live, and you got regular live alongside it and website delivery. That within that delegation model, there really is no option anyway. So you kind of have to give a carte blanche. You would have to, the most granular, the downstream CDN would be able to make a delineation on would be the DNS name. But when we start dealing with HTTPS, 302 redirection models, then the path could become relevant then. I guess where I'm going with this is there's a little bit of a nuance there, including it in the footprint, but actually now that I'm talking it out loud, I still think it's relevant, and it does make sense to try and add that identifier into the footprint as well.
I'll let Chris get into the queue. I see him at the mic.
Hey, Chris.
Seconding the footprint, I think you're right that you're not going to be able to, in many cases, you won't have enough information to determine exactly where in the footprint someone falls. But that's not unique to just what kind of content they're requesting. There's a number of cases where you're never going to be 100% certain where in the footprint, and you just have to do your best. So I think this approach makes sense, and the footprint solves the problem more neatly than the other solutions we've looked at.
Anyone else have any comments on this? If not, I encourage you to read through the comment thread on the list. I know it was late last night, early this morning, for folks. Get in on that. But otherwise,
I'll
go
just up and say that I also like the footprint solution, and I think it's just that we just didn't consider it at all when we were initially drafting this. I think when we started on this, the footprint extensions and footprint unions weren't a thing yet. So I do think that it would fit into that model very nicely.
Awesome.
Great.
Here
Okay,
quickly.
Sorry.
I apologize. When we say footprints, do we mean? I think there are two interpretation of footprints that we use in CDNI, and one is that's a kind of a set of cached resources, and another is set of users. Which one of those is being used here?
This is the footprint that is the part of the definition of an FCI payload. So it's literally that, in the JSON object, right? You've got the FCI components at the top and then the footprint underneath it. And it's, whether it's the CIDR / the CIDR address, the ASN, the GeoIP, or the geolocation component of it, right down on the slide to the right there, Alan, on the bottom, the footprints component. That's what we're talking about there.
I get it. What I'm saying, we never really disambiguated this distinction, and that's something we discussed in our kind of name footprints the discussions in the CTA. Is that really in CDNI there are implicit two different footprints. One is a footprint of users that are being addressed, right? And you define them the way you define them, ASNs, what have you, right? Or you define a set of caches. So I just want to make sure that really is the first. That when you say footprint, what you mean, understand the definitions, but again, this doesn't help. It still can be both. What you mean from capability point of view, you're saying for these users, this limits apply.
Yeah, okay, I see what you're saying about is the nuance, right? So the down in this case, right? It's the downstream CDN is saying we're allowing for, it's really a nuance, and I think this is kind of the point that Chris was coming up with, right? Is you're either kind of explicitly, all of this at the end of the day is really measured by where the user is located, right? So even when the downstream is saying, I'm advertising, support on this ASN or this /24, at the end of the day, it really is tied back to a GeoIP lookup of the end user's information, right? Or if there's some other, method that you can discern from where the eyeball is, right? I kind of see where you're saying though, is that it's really, there's a hard definition of here's the capacity available in this data center, right? In wherever, but at the end of the day, the footprint is really based on the eyeball definition, right? And we're kind of mashing those two together, and I can see where some of the confusion comes in.
Yes, so I think that kind of, again, this is for this nascent name footprint discussion, that I think the realization we come to is that we really are using the eyeball definitions. The CDNI literature kind of actually not very definite on this until you come to some obscure kind of draft, really, not even RFC, that says, well, when we say footprint, we really mean two different things. Is either set of caches defined by IP addresses or a set of users. And I really saw that in all of our discussions, that when footprints come up, we really mean the eyeball. So I'm just making sure that when you think about the capability here, you're also thinking eyeball footprint and not cache footprint. Because to me, the latter really kind of meaningless kind of across the board. So I'm just making sure that we're on the same page. Looks like we are.
CDNI is always based off the user. The intent was never to try and describe the cache infrastructure, because we don't want to expose any CDN's internal infrastructure. They can serve however they want. If they say they can serve in London, they can serve in London. If they're serving it out of Japan to serve London, that's not our problem. I think it's probably a bad idea, but we don't want to take that into account. So we have always said that's kind of out of scope. I think it's written somewhere, but I'd have to go and look. But if it is unwritten, then we are trying to avoid exposing anything about the CDN's physical infrastructure and focused on the end users, what we believe is the end user's location. Obviously, tunneling and that sort of thing. Maybe you can't.
I do believe that is specified in this draft, as well as one, we can't advertise carte blanche all capacity. We can just give you, here's the capacity available for you upstream CDN, because of restrictions just like that. We don't want to allow for someone to reverse engineer like the actual capacity of a downstream CDN per se. And then two, we're explicitly saying we cannot provide SLAs on service. Like, this is a guidance. This isn't a hard rule or anything that you can associate an SLA with in terms of like, penalties or reputation service or anything like that, explicitly for that point, right? This is a best guess, and it's meant to help prevent, overutilization and bottlenecks.
Kevin, I fully agree. I'm not sure that is universally done this way. I think there's at least, but again, this is a different conversation. I don't want to kind of digress, but I'm not sure that footprints are universally understood in CNI as being eyeballs, but that's for another day. I think mostly so, but not universally.
Chris.
Just briefly, you mentioned that this, the way in which this is related to business arrangements that entities might have with one another. And I think we have agreement that that's entirely out of scope, I hope. Okay, I see heads nodding. Good. The question of whether someone makes a business agreement that this will have some sort of penalties or enforced, or is an SLA related thing, is an agreement someone could make completely outside of this, but it's not related to this.
100% correct. Yeah, we once again, we explicitly call out, we are not addressing any component of SLA or reservation at all with this model. This is really a model to signal a happy path that if we have the downstream CDN has a reasonable expectation if the upstream delegates the traffic within the limits they are advertising, performance would be acceptable. But there is no definition really of performance. This is just a loose agreement of if we feel confident we can accommodate traffic at this level in this area, and that's it. It's explicitly called out. There is no any further relation at that point. It's probably something that's going to come down the line, though, but that's not something we're tackling at the moment here.
Okay, I think we have Anant in the queue now, and Kevin. Anant?
Hey, Anand from Edgeo/Limelight. The advertised capacity from the downstream CDN, is that the ingress capacity it's advertising, or is that the amount of egress it can support? Because the egress is a function of the request rate, right? Like a 50 gig file, the upstream CDN doesn't really know what's going to amount to the egress capacity. So what is the downstream CDN actually advertising here? Maybe I'm missing some context.
So in this model here, what we're talking about here, right, is the amount of traffic the downstream CDN is willing to allow the upstream CDN to delegate towards it, right? So in this case, the eyeballs, where previously they may have come to the upstream CDN or like Edgeo. Now, let's just say that Edgeo decides to delegate that traffic towards Broadpeak. What we're talking, this advertisement would essentially be Broadpeak would be telling Edgeo, I've got 100 gigabits per second capacity on Orange in Italy or something like that. You can delegate, you're tracking how much you're delegating over to us, send up to 100 gigabits per second. So that would be egress as measured from Broadpeak.
I see. Okay. And that's done like the decision is done by the upstream CDN on a per request basis then.
Correct, because that's where that's where the initial component or potential component of the eyeball termination would initiate, right? It's if the upstream CDN, like we're dealing with, hey, I'm getting a request, but I want to send this request somewhere else, right? Where the upstream is delegating that to the downstream.
Okay. And so does this include the amount of ingress that so that's not a concern for the upstream CDN then? So the footprints doesn't include anything about the ingress towards the downstream CDN?
We have not put provisions into the capacity API to advertise any limit on ingress. That would be more of a function of the cache fill source, or i.e. the origin or something. That's outside of this scope. That's not a limit that the downstream would really want to would readily advertise, unless for some odd reason we want to account for the fact that the downstream CDN only has, a 10 gig uplink out of the world or something. Like I don't know. That isn't something we've considered in terms of signaling of the capacity. We were mainly dealing with outward based on the relationship of the end user eyeball to the downstream CDN, not necessarily from the downstream to any origin source.
Okay, they could be extended with an additional limit type if there was a use case for that, though.
Mm-hmm.
I just wanted to add that the telemetry is there specifically because the upstream doesn't necessarily have an exact understanding of the effects on egress from the delegated traffic. Particularly something like video streaming where you're delegating a session and then all subsequent requests are going to the downstream. The upstream may not know exactly how much egress is consumed by those sessions. So that's why this is explicitly associated with a telemetry source so that the upstream can monitor that and use that to inform its traffic delegation decisions.
Yeah, sounds good. Thank you.
Thank you. I think we're a little bit tight on the time, so we're going to move on. Just before I close the queue on this, any other questions?
just want to thank everyone for the great feedback today. It's been very productive. Thank you.
Thank you. So I think next we have Neer, if you're still with us, Neer.
Yes, I am.
All right.
Okay. So, hi everybody, happy to be back here. We I would like to discuss the triggers, the trigger interface, and the rewrite of the RFC. We haven't made much progress in since the last meeting. I was less available to push things through, but we hope to make a significant progress now. Sanjay and I am working on that. Can you please do? Sanjay, I control the slides. Yeah.
Do you want me to move through
Yeah.
what is left slide, or this is
Can I
kind of
control it?
covered? Do you want me to move towards what is left to be done?
No.
Okay.
Let's stay like that. So a quick recap: what is the CDNI? What is the CDNI triggers interface? Its interface practically allows the upstream CDN to control the downstream CDN, to manage and control downstream CDN content and metadata. Sorry. Friday afternoon. We haven't changed anything in this perspective, but we worked on the entire structure, or on the structure of the trigger object. Next, please. So far, the triggers object was built of a type, a CDN path. In the last draft, we had some draft before we had the trigger extensions. Ori and Sanjay mostly worked on that. And then we had a set of properties that their purpose was to specify which objects the trigger should be applied on. And one of the issues with this set is that every time we would like to propose a new properties, a new way to select content, we would need actually a new version of the triggers. So what we practically did is pushing it to a generic list of trigger specs. Next, please. So the spec object practically comes to specify what to work on, what items to work on. It has a type that says, okay, it can be URL spec or a pattern spec, etc. How to select the content. And it has also a subject. Are we working on metadata or content? Okay. Both of those lists are now flexible and generic. We can register more types to work on. Next, please. And here is an example for a spec object. In this case, where the trigger, this spec object points to a metadata with this URL. Okay, so if we create a trigger of purge, this metadata, the metadata residing in this URL would be purged. Cool. So just a rename, another change we did is changing the trigger type, the name trigger type to an action, which is, I think, what more straightforward to what it stands for. So it's now called an action. Next. So if we look at the entire trigger in the trigger v2 in the new structure, it has an action, it has a list of specs, that whatever element matches one of the specs would be the action would be applied on. Okay, so in this case, we would work on metadata with, we will pre-position metadata with this URL and content with those URL. One thing we noticed is some inconsistency in the structure of the. It also already comes for the original RFC in the structure of the spec objects. There are specs that are like the URL specs that are generally just strings, URLs, and there are more complex specs like URL patterns that are dictionaries that can with several fields. We can see an example in the next slide. Okay, so this, for example, can be the list of specs in a trigger, and the URLs are just a string, and the URL patterns are practically every element is a dictionary. The URLs is not the only one that is only string. There's also the CCID, and that is practically the same. Next. So what we would like to suggest and change is making for consistency and structural consistency. We would like to consider to move all objects, also the URLs, to a dictionary style list. And to be honest, only an hour ago, when I refreshed, I went again over the presentation, I started to think maybe the block before that is not needed. If can I point in that the URLs and the patterns token can be removed. So just have a list of values of dictionaries similar to the footprint API, to what we have in the footprint API. I'm not sure you are following what I'm saying here because it's not in the presentation, but I think it might be even cleaner to do that. To remove the URLs and patterns, those tokens, and just have the lists. Yes, Alan.
Does the dictionary mean that you can support multiple like free kind of custom values in those or not?
The structure of the dictionary is well defined per spec type, and that it's not it's defined per spec type. You can actually argue, okay, push the spec type itself into the dictionary, but I think it would be less comfortable here.
My question is, maybe you address it later or the different spot, is that we see a need for basically custom values for triggers, custom attributes. Is it something that this will address or not?
And can you give an example? It won't address that, but we can add an open list of something, or if there is specific specs that needs this the flexible attribute list, we can just add a dictionary within it, a dictionary within the dictionary. But I would be glad to if you have a good an example for that.
Yeah. So for in kind of, we were looking at the, as part of the kind of content management, cache management spec again at SVTA. We're looking at various ad hoc or custom attributes that would be added. For example, bandwidth policies around prepositioning, right? Do preposition, but do it only on Sundays. Preposition, but use no more than 100 gigabits or 100 megabits. Preposition by, and do this by in 7 days, things like that. And
Okay.
kind of, and every other time that, so what I'm saying, I guess triggers can become really hairy. Kind of, they can be a lot of different attributes. It would be good to have a mechanism to extend that without revising the whole spec every
Okay.
time.
It's I'm glad you used the term extend them, because this is partly what the trigger extensions does. I haven't referred to that because it's didn't want to overload the session. But the first, when we started to work on the RFC, we actually had a draft that was a standalone draft with that adding the trigger extensions that allows you to specify that you want the trigger to be executed on Friday night, 3 a.m. only in Brazil. Okay, and the extension is also generic, and we can redefine more and more extensions. This is part of it, was integrated into this RFC, and if you see, I would be glad if you will review that, and if you had any additional idea for additional extensions, let's already add them into this RFC, and that would be valuable for all of us.
You actually take it into a different direction than I was thinking. I think I was thinking kind of extend the attributes that come with trigger, which you kind of, you say, hey, we want to restructure the way we do this. We want to do dictionaries. Let's kind of define trigger payload differently. And I was thinking, hey, we want to provide a way to easily add values to triggers of specific types without changing the spec. But you're saying also something else that maybe actually whole different dimension is, how do you run triggers? I want to run triggers repeatedly. I want to run triggers a certain time, which is not what's in the trigger, but how do you run that? Which I haven't seen that kind of. So that's also interesting, even though that's new to me.
Yeah. So this is also already in the draft. It's presented. It is presented there, and if you see what the spec practically needs to comes to specify what to run on. So if you have, and there are patterns and regexes and about 8 types of specs. If you think there is a need to an additional spec, or one of those specs need to be extended with an open list of properties or something like that, we can add that if there is a specific example that show the need for that.
How about we take this to the mailing list? We are out of time. We've got a couple more
I will
items.
to continue there. Yeah. So what ahead of us? We first of all, I would like to make we would like to make the change of the structure of the specs of the URL and the CCID. Then we would as we took the original RFC and just add a thing to it, we need to reread it in a fresh mind and verify that everything is consistent. And we hope that by the next IETF meeting, we will be able to get for the working group let's go. And by the way, thank you, Kevin, for the shepherding in the footprint RFC, footprint type RFC.
You're welcome. Looking forward to reading the updated draft, and I encourage everyone when they see it come out on the list to please review it. There's a lot of good stuff in there, and we want to try and get it right this time.
Thank you, Nir.
Thank you.
Okay, I think we have Chris, you on the next here.
In today's episode of Hot Drafts from the CTA, we have the streaming media tracing. Next slide. Talk about who they are, if you're not familiar already, and what we're working on and why you might care. Next slide. So this is work being done out of the CTA, the Consumer Technology Association. Their web application video ecosystem, the WAVE subgroup, and the primary motivating use case for this is streaming media. But as you will see, it may find itself more broadly useful, or it may not, depending as the work develops. The ultimate goal of this particular group is interoperable tracing, specifically interoperable tracing for streaming media. But it turns out that streaming media isn't that different when you just do it over HTTP. So there may be some interesting utility. Next slide. So right now, we're near the very beginning of the process. We've scoped out the work that we want to accomplish. And we've determined that there are basically 3 big legs of this work. There's the pull, the push, and the export. So pull is the stage of a request. Client asks an intermediary like a CDN for content. Intermediary asks an origin for content. Each of the entities is attempting to pull content from the next up in the chain. And we want to be able to trace this as we go through. The second piece is a little bit less well understood, but the basic idea is that origins don't get their content from nowhere. Usually, their content comes from some sort of a processor that may, or transcoder, something that modified the data, and that got it from some sort of a source. Very often, if we're talking, for example, video content, it may have come from a camera. If we're talking about audio content, a microphone. And we would really like a interoperable way to move this data around in a way that moves with the data as metadata on the envelopes, and lets us measure latencies, identify problems. This data is primarily forensic in nature. And that brings us to the third leg, which is the export. So we've moved this data around on the objects, on the envelopes. We probably want to send it to a logger somewhere, right? We aren't quite sure what this is going to look like. There's a solid chance it's going to look a lot open telemetry-ish, but the work group hasn't actually started really digging into that. So that's just a guess at this point. Next slide. So right now we're at the beginning of the pull part of the stage, which means we're defining request and response headers for HTTP in particular. We have a request header that provides visibility into the request chain, so that when an origin receives a request, it knows, roughly speaking, what route it took to get there. We have a response field that provides visibility into the response chain. When a client gets a response, the client then knows what the entities responsible for preparing that response for it are. They both use structured field values, and they represent a graph of the trace. And this graph concept turns out to be really important because all of the existing processes and headers that we would talk about like this, things like the cache status header and the proxy status header and the CMSD dynamic header and the VIA header even. Those are all agglutinative headers. They just add up as you go. And that's fantastic and it's valuable, but it only captures the successful part of the trace. It captures one linear representation of how the data got from origin to client or vice versa. And so one of the things that we want to make sure that we support here in this particular work is we're trying to represent the graph of the trace, which includes the unsuccessful flows. Next slide. So the format that we have, and to be clear, our group has not fully reached consensus. This is in fact a work in progress. So this uses structured headers, and the field is a list of sublists. Each element of the list is a server, intermediary, or client, basically a participant in the HTTP flow. Each element of the sublists represents one of their requests, which may or may not have been successful. An intermediary that simply attempts to make a request upline and never gets a response to the ACK, that's useful information. We'd like to be able to store it in flow. And so just because there's a request doesn't mean there was a response, for example. Sublist elements, so these are the elements of the sublists, are relative indices that indicate the target of the request. In this way, we create a graph. Next slide. I am not going to go into deep detail on this, but this is what a full chain might look like if it were exported from a client. You kind of read it bottom to top. The client is at the bottom. You can see that it has one element of its sublist, 0. That says it made one request. That request was to the thing directly above it. The item marked intermediary. That has 2 elements in its sublist, 0 and 1. That tells you that in order, it requested 0, which is to say origin A, and 1, origin B. It didn't give us any information as to why it requested multiple things, or why origin A failed, or any of that. But it tells us what the shape of things looks like. And you can see, if you were to draw that out in a graph, what it might look like on the right. Next slide. You can add data to this. Lots of data. We're not going to dig into this, but you can see timestamps, you can see durations, you can see times to cancel. You can see that some of the things might have been synthetic because I never reached them in the first place. Lots of good information, and we're considering, we're currently scoping out what all of the types of information we're going to store. Obviously, timings and latencies are super valuable. You can see times there. We're aware that non-relative times are not super valuable. There are some use cases where you need them, though. Next slide. So we're still near the beginning of the pull stage. We're working on the details of the data format. Nothing is set in stone. I'm not even sure it's set in mud yet. We're starting with the timing data, but we're expanding to store many more additional formats of data. We are looking at the aforementioned agglutinative headers to see what pieces of those data it is useful to define, whether we can simply delegate to those headers and their formats and their definitions, because we'd like to not reinvent anything that doesn't require reinventing. And we'll be defining more as we go. Next slide. Why do you care? Why am I talking in front of this room? There will be eventually configuration elements. CDNI may find it useful to allow these elements to be configured. It may not. That will be something that will be useful to determine at some point in the future. This streaming media tracing will eventually offer export, logging. These interfaces are likely to be of interest. It's hard to tell what they're going to look like. They may fit into CDNI-shaped logging things. They may look open telemetry-ish. We're not sure, but we want to make sure that you can be part of the conversation if you wish. Next slide. Questions? I know we're running.
I think we're out of time. I'm sorry. We can't have questions. We're going to have to take it in the mailing list. I do want to give some time to Alan, as he had requested some time on the open mic, to see what, few minutes that he has. Thank you.
Thank you.
Thanks, Sanjay. So I share slides. Did you get them, Sanjay?
No, but see if you can.
I can probably ask to share. Yeah, that
Yeah.
works too.
I stopped sharing here.
Asked. Yeah. Yes. Right. Oh no, it's actually asking. It's choose deck to share. It would be something that you share, not something I can share.
Okay.
Share screen. Yes. Yes.
Okay.
Yes. I do really want to share my screen. Yes. Share. Okay. It's kind of recursive, and that's a topic. So very quickly, so this is work that was started by Guillaume, and I was helping along to bring to fruition. And that's a spec that we kind of are working on at SVTA, and there will be a draft we'll be submitting to the next IETF. So I just wanted to do kind of quick heads up on the work we're doing and that's coming up. A problem statement and why we are doing what we're trying to do is that a number of group members kind of came to the front saying that we need to include embrace recursive request routing, HTTPR, in the open caching implementations. And there are a number of motivations. One is latency reduction. You can see on the right kind of schematic description of delegation. Today, let's say practical open caching implementations utilize iterative process, which requires the user to go to UCDN, and then UCDN in some shape or another, depending on the method, redirects the users to DCDN. So by using recursive, we seek to reduce latency so that we fewer round robin trips, RTTs kind of back and forth. Additionally, the motivations are around UCDN wanting to retain control over what gets delivered to the user. In iterative approach, the content gets served by the user by the DCDN and without any visibility. And UCDN may implement some logic that it wants to, for example, server-side ad insertion, where they want to utilize some control over what gets delivered ultimately. Want to consolidate downstream CDN, but want to be in control. And last motivation is session-by-session admission control, where kind of DCDN wants to admit a session-by-session as opposed to kind of bulk delegation that happens in the iterative approach. So that's a motivation. When we're looking at what's CDNI specified until now, it's RFC 7975. And it embraces both DNS recursive and HTTP recursive. And the way it works at very high level is that UCDN and DCDN exchange kind of JSON encoded requests and responses over some control plane. And it has several deficiencies. So first of all, that only delivers basic fields of the request. In many cases, we want to see all of the requests to make a decision. There's really no latency reduction because there's no ability for DCDN to deliver the response to be sent right away. So usually that would mean DCDN tells UCDN, oh, go to this destination, send the user to this destination. So really no latency gain, still has to do redirection. Pretty complex to implement because that's you kind of really encoding requests over some custom protocol. Many situations not desirable, so you just really want to forward requests as opposed to re-encode it in some kind of ad hoc format. And it only delivers requests to the DCDN, and as you will see next, in some cases, response is needed as well. So out of this, we're proposing kind of updated request routing interface. And these are the key features. First of all, we kind of common HTTP/S based open caching interface. It will provide backward compatibility for RFC 7975 flare of this kind of JSON messaging, only if because we want to support DNS-R, and this is a way to do this. Kind of, I don't know how much practical value there is, but I think certainly we want to support both DNS and HTTP recursive. The main difference or change is that as opposed to encoding requests in some format, we want to actually forward UCDN and DCDN exchange requests and responses as is. So latency can be reduced. So kind of request forwarded to DCDN, DCDN can respond, and the UCDN can send the request as is down to the user. So we're gaining the latency and simplify implementation. Really, something can be done in a pretty standard kind of cache proxy chain mode, as opposed to kind of creating some form of control plane protocol, which is what RFC 7975 proposes. So UCDN may forward the DCDN response to the user without change, because the implementation makes it easier and straightforward. We saw two different modes that are needed for operation, kind of depending on how DCDN is provisioned and configured. And then one is in request mode, where UCDN gets a request from the user, sends a request to DCDN, DCDN acts on it, and usually that will require DCDN to have independently configured to get content from somewhere, from the origin, from UCDN, and so on. And there is there is a kind of really a proxy chain that gets created. In response mode, a situation where DCDN doesn't have independent access to the content, or there is some custom logic that is happening on UCDN. So in this case, UCDN will supply not just the request, but also the response as UCDN would send it, and then DCDN would act on that. And the spec proposes kind of support for both, and also dynamic change from one another. You can start by asking for giving the request, and DCDN say, well, hey, yeah, I got it. I don't have enough information. Please give me the response you would have given to the user, so then I can tell you how to change that, or can I support that? Not going into a lot of detail here, lack of time is something I guess we'll hopefully do the next session, but there is a detailed kind of diagram of the request mode. Will support HTTP 302 redirection and manifest rewrite from the DCDN. So UCDN can give the request to the DCDN. The DCDN can just respond. Yeah, sure, kind of get it. Here is a response. Please provide it for me. Or including change of the content, and can be 302. It can be also error conditional. Like I cannot support that. Sorry, that's not a session I can support. We talked about granular session control that would provide a way to do that. And it can also provide dynamically say, well, get it, but I don't have enough information. Please give me the response as well, which kicks us over to the next mode, where a UCDN provides a response to DCDN, and then DCDN makes a decision on any of the changes it wants to do, let's say manifest rewrite or content compression, or decisions for delegation redirection that are based on the response. Request not enough. You can kind of stand that what kind of size the objects are, maybe MIME type, and you can decide whether you want to redirect this content to DCDN or not. So that's a high level, right? Again, we will bring you forward the spec. It's in final form now, going to SVTA review as well. And we'll welcome comments and working with the group to getting this into CDNI.
Thank you, Alan.
Thanks, Alan. Looking forward to seeing the draft.
Okay, so I think we are a few minutes over, so I really appreciate everybody's time. I know it's Friday, it's late here in the UK, and late afternoon, and I know it's early in the morning, and some of you that are in the US, and probably late in the day somewhere else that you're on the east side of the continent. But I really thank you, everybody. Great session, and I really encourage that those who could not ask questions to go onto the mailing list and put your question in on any of the drafts that you heard or presentation from Chris and from Alan. So feel free to do that. Alan, if you, since you have sent me the email, I will send that into the distro, into the CDNI mailing list, so that folks can see what you're proposing. And yes, definitely, we'll look forward for you to submitting a draft.
Thanks. Yeah, we'll do this shortly.
Yes. Kevin, anything you want to add?
Nope. Good job, everyone. Thanks, and we'll see you at the next IETF. Safe travels.
Thank you, everybody. All done.